YAML itself, and then we're going to talk about workloads like pods and jobs and such. We'll do a little bit on networking and services, not a lot, but just enough. A little bit on storage, and then there's some more detailed workloads we want to hit, and then we'll talk about configuration and creating your own types of objects known as custom resources. All right, well, it would help if we went down instead of up. All right, quick refresher. Namespace. So this is a basic YAML document. Okay, what you see is lines of data with pairs, name value pairs. Okay, these are maps, and you see that things are indented. Okay, so this name is the value for metadata. Okay, this I shouldn't say this name. This name webinar namespace map is the value for metadata. So it's indented so that we can tell. So what we're going to do here, and this is what we're going to do on this webinar, instead of kind of PowerPointing you to death, I am going to actually demonstrate all of these code listings, which is why I say to you, I think we'll give them to you in a Git repo of some sort. So if I copy this, I'm going to use a tool called Lens. So I'm just going to create the file here. And Lens is not running. Why isn't Lens running? Come on, Lens. There we are. So Lens is a great IDE for Kubernetes. I already have my cluster created and everything. I only have one node in here because, I'm not creating anything amazing. But it gives you a good overview of everything that's going on, and it also has a terminal that always has the correct kube control for the cluster that you're working with, which I find incredibly handy. So what I'm going to do here is I'm going to go ahead and I'm going to kube control create object YAML. Okay. So it will tell me that we went ahead and created this namespace. So let's go back and look at the text again. There we are. So we've started out with the API version and the type of object, the kind. So you will see these on all Kubernetes objects, API version and kind. Okay, the API version is so that you can so they can handle backwards compatibility. So some things you'll see they started out as beta v1 or v1 beta whatever. So in this case, this is a v1 object, and the kind is namespace, and it's got data about it, okay, which would be the metadata. So the name, every object has a name. So we're going to go back over here to Lens and take a look. If we go down to namespaces, we see that our namespace was created. Okay, now here is a trick for you. Every object that is stored in Kubernetes is stored as YAML. And you can create these objects as YAML. And sometimes you might find yourself in a situation where you're not sure exactly what the structure of the YAML you need is. And one trick that you can use is find a tool like Lens, or just use the kube control edit command, whatever. We can do a whole webinar on kube control and the command line if you want, but for right now, we're just going to deal with the YAML. And you can look at an existing object, okay? So if I come back here and I look at this namespace that I just created, we see the things that we had put in, okay? But we also see additional data that Kubernetes itself added in. So like the UUID, resource version, and so on and so forth. Okay, we don't need to worry about these things. Okay, if we were going to create one of these ourselves, we could go through and add some of these, like if we wanted to add a particular finalizer or whatever. We're not going to get into that today, but we could if we wanted to. But you can pretty much tell which things are the things that you need, right? But that's a trick that you are definitely going to find useful. So, all right, so let's go back. We've got our basics. All right, this is our YAML document. We create it. This is the results. So let's start actually looking at real workloads. Okay. Now, most basic object is a container. All right, you're already familiar with containers. You know what containers are. You know that you build them from an image, such as Debian. If you were going to create this as, say, a Docker container, you might create a Docker file that has the command and arguments that you would use to start up that container. Okay, and we have something similar here in the YAML that we'll use to define this container. Okay, so here we're going to say, oh, we want to execute the command echo, and what we want to execute from there is hey you. Right, so this is pretty simple YAML. This is an array here, so I mean we could put it down underneath with we could put it down like this, but I'm not going to do that because the formatting gets all screwy. Instead, I'm just going to come back to where we were. But here's the thing. Kubernetes cannot create a container all by itself. The smallest unit in Kubernetes is the pod. Okay, so what we need to do is we need to take that container and make it part of a pod. So here again, I'm specifying the API version. I'm saying a pod is what I want, and I'm giving it a name, and I'm defining that pod. And what I'm defining is I'm saying, okay, the containers that are in this pod, and I can have more than one, that's why this hyphen is here, but in this case I'm only having one, and I'm going to put that container that we were just talking about. I'm also going to say, unless this thing fails, don't bother restarting it. Okay, because this is just one simple command, and then it'll be done. So let's see what happens. I'm going to take this code, drop it into my file, come back to Lens, and I'm going to come back to the terminal and run it. I'm going to put this actually in the webinar namespace that we created earlier, just to make things a little simpler to clean up. So if I come over here and I look at pods, well, I got nothing in the default namespace, but I do have something in the webinar namespace. Okay, so here's my demo pod that I created. All right, and I can see that it's been completed. And if I look at the logs, well, there's the output. So we have a simple pod with a single container that just executes a single command. Okay. Now, if we want to get a little fancier, let's say we want a pod that is going to use environment variables. Okay, because a lot of times setting environment variables in the pod is an easy way to get information into the container. So we've fancied this up a little bit. We added some labels. Again, we won't go into labels in this webinar, but if you're familiar with Kubernetes, you know what they're for. We're going to change our command over to print environment variables, and this is the array of environment variables that we want. From the pod, of course, is not a standard environment variable, but we can define it here in our pod definition. So let's take it, save it, run it. Back to the terminal first. Okay. There's our command demo. All right. Look at the logs. There we go. There's our three values. Including the one that we specified in the definition. Okay. So if we come back here, there's some other things that we can do with pods. For example, we can reserve specific resources. So if we have a pod that is going to need, say, a particular amount of memory, or it's going to have a lot of different, it's going to be very hard on the CPU or so and so, such and such. We can specify that in the pod definition, and that will tell Kubernetes, oh, I have to schedule this to a node that has this available. Okay, so you won't schedule a massive pod to, a tiny little machine. Okay, so those are standard pods. And then one more thing in terms of basic workloads is in terms of deployments. So these pods that we ran, you'll notice that they just ran and they completed. Okay? But a lot of times what we want to do is we want to have a pod that's going to continue to run. For example, in this case, I can start up a web server. I can start up an Nginx web server. I should actually point to that. And have it always restart no matter what. And I can make sure that I have 3 of these available just in case. So again, API version. In this case, we're in the apps space and not just plain v1, because this is not a core object. Our kind is a deployment, name as usual, and then we're specifying. So in this case, for deployments, we need to say how many we want, and we have to say what pods actually are part of this deployment. So remember, we were talking about labels here. Okay, so in this case, I had purpose equals demonstrate command. But if I have a bunch of pods that are labeled app equals nginx, they're part of this deployment. Okay, so the template is going to define what should these pods that I'm creating look like. Well, they should have a label of app equals nginx, and they should have a specification of I want a container, an nginx container, and I want it to be named demo container. So let's see what happens when we run that. So if I bring that over, okay, come back to the terminal. When I run that, okay, so it's created my deployment. Now, before I even had a chance to show you the deployments, it had already created the pods. So here's our deployment, and then if we look over in pods, we see our pods that are prefaced by the name and then a random, well, reasonably random number, okay? If I were to look at one of these pods, I could see it's got the label app equals nginx, which is what we were expecting, okay? And also, it's part of a replica set. Now, replica sets used to be what you would use to control multiple pods. And you still can, but they recommend that you don't because you want to kind of go up one level in abstraction and use the deployments instead. So I'm just going to point out that's what it is. Don't worry about it. You don't need to worry about it. Just think about the deployment. Now, let's see what this deployment does. What happens if I were to, say, kill this pod? Well, it's marking this one as completed, and it's creating another one so that I always have 3 running. That's the idea, is I said I want 3 running. I always have 3 running. Okay? All right. So let's go back. See where we are. So that's our basic workloads. All right. Now, networking services. I'm not going to go into networking a lot, but you do have to do it a little bit. So let's take our deployment that we had before, and we're going to add a port through which we can access this container. So let's come back here and look at this. So for the container, we've added a port, and we've specified that port as port 80. Okay? So any requests that come into port 80 for this container should be processed properly. So let's see what happens. Okay. So now, if I were to go ahead and create this, deployment already exists. So One thing I love about Lens is I don't have to do group control, delete whatever the name is and all that. I can just remove it. So, all right. Okay, Nginx deployment created. All right. Now, the thing is, as you all know, or as you may know, just creating the deployment and specifying pods does not create services for you. This is a service I created earlier. As you can see, age equals 59 minutes. All right. So what I can do, the easy way to do that, the sort of cheat way to do that, is to just expose this deployment. Okay, so it's exposed, and there's my service for this deployment. Okay, if I look, I can see I've got 3 endpoints because remember I have 3 replicas, right? And they're all on port 80 because that's what we said we wanted. All right, now I'm going to get rid of this service and come back here. What if I want to be more prescriptive?
I think we might have lost Nick, guys. Just give me one moment. We'll get him right back on.
Okay, I apologize for that. I am sure you guys missed some of what I just said, so if you could tell me in the chat what the last thing you heard was, I will pick up from there. So that's what happens when you use a browser-based system. Okay, I don't know. All right, well, I'll just go back one slide and we'll go from there. All right, to share my screen. Okay, I hope you can hear me. Where were we? All right, deployment. So we created a deployment with a container port, and now what we're going to do is we're going to expose it. I think I already exposed it. Yes, I already exposed it, and that created a service that directly pointed to the 3 replicas in the deployment. All right, now I can do this more directly as well. So if I were to remove this service and then come back to my code, I can create a service directly. Now let's see what happens when we do this. What we have is got a service. We're saying that the port we want to connect to is 80, but we want people to actually connect to port 9600. So let's go and see what happens here. So I'm going to go ahead and create the object. And if I look at this service, I hope it's the right service. Let me make sure. Yes, this is the one we just created. And you'll see it's pointing at 9600. But if we make a request, it will go to port 80 on the container. Another way that we can handle this is you'll notice that it created these endpoints automatically. Okay? We could I'm going to go ahead and remove this. Oh, I know, that's why. Yeah, okay. Remove this. I'm going to remove these endpoints. We also have the option to create service and the endpoint directly instead of targeting it directly at the deployment. Okay, so if we had some service that needed to point at something that wasn't easily accessed through Kubernetes like that, we could do that. Did not find expected. Okay, so we got our service, line 7. Let's see what we got here. Everything looks good. No, that's where we're going. Okay, sometimes this gets a little bit hairy. All right, so we've got our service and we've got our endpoints. So we only ask for one endpoint, and we want it on port 9376. So that's what we got. Okay, but we got it on 3 IPs because those were what we specified in the endpoints document. So we got our service and our endpoints. Okay. Now, let's come back here. No, we only specified one IP on this one, and that's all we got. We got a little bit hairy there on what we were looking at, but we're okay. So, let's come back to endpoints. This is why I was thinking 3, because I have this document right here. Stop. I don't want to look things up. I have this document here where we're actually going to go ahead and specify 3 different endpoints. So let's look at this. We're specifying endpoints, we're naming them, and then we've got different IP addresses, but each IP address has the same standard set of ports. Okay, so if I were to go ahead and put that in, well, I hope if I just saved it and ran it. Try not to make you guys dizzy. I'm sorry about that. Making myself dizzy. Okay. So here's my test cluster. And we can see we've got each IP address and it's got its port information. Okay, now I'm going to go ahead and remove that. And this is a handy thing that we talked about in the last webinar. And that is these references. Okay, so all these ports were the same. There was no reason we had to put them in individually. So we're defining one with the ampersand, and then we're just using them. Okay, so save that, run it, and we get the same thing, 3 IPs, 3 standard ports. Okay. Again, if you have any questions, drop them into the question pane and we will get to them. All right. So that's the very, 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 very basics of networking. There's lots more that we could cover, but we only have an hour, so we're not going to do that today. All right. Storage. So, it's great that you can do things, but without being able to store anything, you have a problem. So the simplest type of storage is when you are basically just creating a directory in your for your container to use. So let's look at this for a minute. Bring it over here where it's a little bit easier to read. Okay, so we've got our pod, and we have our metadata. That's not important right now. We have our spec, and normally when you see this, they'll say, oh, here's your containers and define your volume mounts, and then they talk about volumes. No, let's talk about the volumes first. So we're defining a volume, okay? We're not really creating anything. We're just defining a volume. In this case, we're creating basically an empty directory in the container. Now, there are lots of different types of volumes that we can use, ephemeral, persistent, blah, blah, blah. I'm not going to go over that today. Again, we can do a whole class just on storage in Kubernetes, but the important thing here is we're defining a volume, and then from within the container definition, we are creating a volume mount with a mount path. So this would be the path within, if I were to do, cd/demo-pd. You can't see me air typing. And we're referring back to the my volume that we created. Okay, so if we went ahead and, I can't remember where I am. If we went ahead and created that, all right, command demo already exists. Let's go back to pods, get rid of that, move. Okay. And we can see that volume, there we go. See, my volume exists as part of the container, and we have a mount within the container. All right, so where are we? I've lost track. Here we go. A little bit more about storage class. So the thing about storage is there are so many different things you can use for storage, so many different vendors that have storage solutions for Kubernetes. We couldn't possibly go into anything comprehensive today. The important thing to know is that you can create a storage class which defines what you are going to be creating these volumes out of, and then specify it as the default. Okay? 99% of the time, you're not going to have to create your own storage class. But I put it here sort of for completeness. If you're going to have persistent volumes, there are two objects that you need to think about. One is the volume itself, which has things like the capacity and, can you write over it, or is it read-only, etc.? What is the type of file system? Where is the server that it's actually located on? And so on. In some systems, you will create the persistent volume first, and then create the claim through which you will access that volume. In other systems, you can, so for example, on Google Cloud, you can create the claim first, and it will handle creating the volume for you. So I'm going to come over here. I'm going to create, because it's simpler for what we're doing today, I created a persistent volume claim. Okay. And it went ahead and it created the volume for me, and I could see that it's linked to this claim. Okay. So let's look at the YAML involved here. Again, these are standard: version, kind, metadata, and name, and spec. Okay, you're going to have that in everything, pretty much everything. The basics for persistent volume claim would be, what do you want to do with it, and how much do you need? Okay, and then we could actually look at the volume that was created. Again, we can select the volume and edit it, and we can see the actual real volume that was created. And this would tell us even, sort of where it is and so on. Now, again, we don't typically need to do this, okay? But, it's just nice to know that you can. Or maybe I'm just, inordinately curious. I don't know. All right. So, coming back to our plan. The volumes themselves, we talked about, creating volumes, and this probably should have gone up by the pods, but here are some of the different types of volumes that you can create. So we used empty directory. An empty directory is great because it's easy, but when the pod restarts, and the container restarts, actually, I should say, it's gone. So you might want to use something like host path for something more permanent, or persistent volume claim. All right. Whew. Some additional workloads to look at. Daemon sets are, so a daemon set is basically a pod that runs on every new node. Well, I should say on every node. There are ways to limit the nodes on which it runs, but we won't worry about that right now. So if I were to take this and run it, we could see, so it created my daemon set. There's my daemon set. Okay, FluentD and Elasticsearch. It's only got one pod because I only have one node. Okay, remember, we only did one node because we're not doing a lot. And then I can come up here and see in my pods, there is my daemon set pod. Okay. Alrighty then. This is pretty much the same, except a little bit more information. So, for example, we can do the same types of things with daemon sets that we can do with pods, because basically they're pods. They just are pods that happen to run on every node. So, for example, we had talked about reserving resources. Okay, in this case, it's less about finding a server that has those resources and more about making sure that those resources are available for this pod. Another thing that we can do is taints and tolerations. That's kind of a topic in and of itself, but you can have a node that is what they call tainted. In other words, it has a notation on it that is meant to keep certain pods away. Okay, so for example, you would have a taint that says, this is a master node. If it's a master node, don't schedule on it. Okay, but you can also have a toleration that says, I don't care if that's tainted, I'll tolerate that. scheduling me there anyway. So that's what that's for. All right. Another couple of workload type things, cron jobs. So here we have cron job is exactly what it's like on a Linux machine. It's something that happens on a regular schedule. Schedule's even specified in the same way. In this case, you have a cron job which incorporates a job, and the job has a spec, and the spec incorporates a pod which has a template which has a spec. So it's a little bit of inception here, but finally you get down to the actual container, and here we're just giving a simple message out. So if I were to run it, come on. If I were to run it, I've got my cron job created, okay, and it's going to run on schedule, and it's going to create jobs. All right, so let's go back and look here, and I forgot to remove this job. This is my job from earlier on today, so let's remove that. That's the job I was actually going to show you next, which was this one right here. So we're just going to let the cron job run a little bit because we need to wait until it does its thing. So let's look at what we have. So our job has our name, and it has what it's going to do. This is the pod, same as before. It's the name of the job and the spec, and this is the container that we're going to run and what it's going to do. Okay, and we're saying don't ever restart this. Okay, once it's done, it's done. So let's go ahead and run and create it. Okay, there's my new one right here. Okay, and the container itself, the job itself doesn't do anything. What the job does is it creates a pod, okay? And there's the pod, example job. Remember, it's the same thing that we had with the deployment. There's my job. It creates the pod. And there's our output. And we said just output all the digits of pi. Well, not all the digits of pi, but you know what I mean. Okay. So, if we leave our cron job long enough, it's going to go ahead and create jobs, but we need to leave it for a little while. All right. Now, next, configuration. In our last webinar, we talked a little bit about config maps. So config maps are a way to kind of specify various information. We used these when we were talking about data types. I'm not going to worry about the data types so much today, but I want to show you how to use the config maps once you've created them. So here we have this config map that we created. Okay, app config, and these are the three fields that it has, and we can change them. You can edit these if you want to. I'm just going to leave them as they are. Another handy thing that Lens lets you do. So I have my app config map, and I want to use it from a pod. So let's take a look at this pod back here. So standard pod, same pod we had before, only instead of just specifying our environment variable from the pod, we are getting a value from a config map keyref. The name of the config map is app config, and the key that we want is wait. So if we save it and run it, hold on. I keep forgetting. Let's just take a quick look here. So app config weight is 42. So if I come back here to pods, command demo, remove, thank you. Should name them all differently. Oh well. Command demo. Look at the logs, and there's our 42. Okay. We create secrets and use secrets in a similar way, not quite the same. Secrets are created as objects and then referenced as volumes, actually. Okay. Running out of time, so I'm just going to kind of move quickly through the last section. So the last section would be custom resources. You have the ability to create custom resources. Now these would be resources that do whatever it is you want them to do. All right. Now, in this example, I am going to, so some examples of custom resource definitions would be like KubeVirt is a CRD, which lets you run a virtual machine as a container or inside a container, and so on. Okay, they do fancy things. The actual custom resource definition part, however, is pretty straightforward. We're going to create one called a banana. All right, we're going to create a banana. So API version would be extensions.k8s.io/v1. And what we are creating here is a custom resource definition. Right? Now, the full name for this definition would be bananas.nixfruit.com. It has to be, you have to have it in a group, which is kind of like a domain name. Okay? So I'm specifying the group name here. And the reason that you have to have that is you may or may not be familiar with this, but Kubernetes is all done through the REST API. Well, can all be done through the REST API, in which the group is part of that definition. Okay? So we say, all right, the group is nixfruit.com. I don't know if that actually exists. It's totally arbitrary. You can have multiple versions of which only one may be served at a time. Okay? I'm sorry, only one can be stored at a time, but you can serve multiple versions. And then what you're doing is you're defining what this thing is and what properties can it have. Okay? So in my case, I'm creating an object that has two properties. One is ripeness, and that is going to be a string. And the other is whether it's still on the bunch, that particular banana, and that's going to be a Boolean. Okay? Now, these custom resources can exist either cluster-wide or in a specific namespace. I'm going to go for just namespaced. And we need to know what to call it. So it's a banana or two bananas, and the kind, we need to know how to reference it. And just because everybody likes the camel case, we're just going to camel case banana, which is kind of silly, but whatever. And then a short name in case you're just too lazy to type banana. And I referenced the person who thought that PO would be a good abbreviation for pod, thus causing many, many comments from people saying this line of code is incomplete. No, it's not. Okay, so let's see what happens. So if I create this custom resource definition, I come back to Lens, there we go. I create this custom resource definition. I can come down here, definitions, bananas, okay? Now, I created a banana earlier and I forgot to delete it. See, 61 minutes. So at this point, we should not have any bananas because we hadn't created any. Yes, we have no bananas. Now, if I want to create a banana, we will come through and, by the way, this is a good lesson for you. Just deleting the definition of an object does not delete those objects. Okay, so for security's sake, if you want to get rid of those objects, get rid of the objects themselves because somebody else could reinstate them just by recreating the CRD. Okay, so be careful. Now, if I want to create a banana, and if only it were that simple because I could really use a banana right now. If I want to create a banana, so again, API version, now remember, we've got the group, in this case, Nick's fruit, that's what we defined, and the version, because we defined that we wanted version 1. And then the kind, we specified as banana, camel cased, and we named it my banana. And just because we already have the other banana there, I'm just going to call this my banana. We're going to say, yes, it's still on the bunch, but it's so ripe, let's make bread. Okay, so let's take it over here, save it, whoops, save it, and run it. Okay, now, so if I come over here to bananas, there's my other banana. Well, of course, now it's gone. I can edit it. I can see that it's got the fields that I added, such as, where is it? Such as on the bunch and true. It's got all of the other sort of auto-added things that Kubernetes does on its own. And then we can do something else that just kind of makes me laugh every time I do it. I'm sorry. But kubectl get bananas with our namespace. And there you go. There's your other banana. Now, obviously this banana doesn't do anything. Okay? Creating the mechanism behind it, you know, use the API and so on, that's a whole other, that is a whole other conversation, and we can do that. Now, that brings us to the end of these slides, okay? Now, I'm going to answer questions here, but I would like, before I get to the questions, I do want to ask you this question so that you can tell me. And that is, we're doing this whole series of, you know, learning Kubernetes. What topics do you want to see? Do you want to see more on networking or storage or you know, how to create, you know, the back end of these objects or all of this stuff? So that is what I would like to see from you guys. You can throw it in with the questions if you want, or throw it into the chat. Erica, if it's not going to work on the chat, you tell me, and we'll go from there. But all right, now, so let's kind of dive into the questions. If you haven't asked them yet, now is a really good time.